Hi and welcome to Geology. I want to go a little bit through the Google Earth geotours for Chapter 2 on plate tectonics. And I've already have the quiz open here on Canvas. And the first question is asking us to measure basically between conjugate points that were once together but now are separated along the Mid-Atlantic Ridge using the ruler tool. And more particularly, we're going to use this path tool. And so if we do that, let's go over to Google Earth here. I have it open already. So one of the first things we want to do is we want to click on plate tectonics, letter B here. And that should open everything up, right? So if we expand that, we see that we have the seafloor ages, earthquakes, and all the problems, right? So I'm going to double click problem 1 and just go to problem 1. And so you can see that I have the seafloor ages on there, and here this bar shows the different ages of the seafloor. One of the things you can do to reduce the overlay, the transparency or the opacity, when you're on the seafloor ages, if you highlight the seafloor ages, and then you go to this this option right here, that's adjust the opacity. Click on that, you can bring this down, you can see more of the features of the seafloor. So you can kind of play around with that, or you could toggle between having the ages of the seafloor shown, or you can just turn them off. And so they're asking us to measure between these two conjugate points. One is right here, and the other one is way over here. So if we zoom in on those just to kind of take a look at them, so it should be problem 1, and then the other conjugate point is over here in Africa, problem 2. So using our ruler tool, we'll click on this, and more specifically, we want to use the path, right? That way we can click and stop in different areas. So we're going to start here, right? And then we're going to go here and just kind of follow this fracture zone here. And you want to push this button here. You don't want to push anything in here because the path will end up going there. So we go there, and we find we got about a little over 5,000 kilometers, right? So on the problem here, we're going to round to the nearest 1,000 kilometers, 5,000 is what you want to pick. Number 3, it wants us to calculate the average spreading rate. So once you establish the age of the seafloor here in problem number 2, whatever you get, then remember, the rate is always going to be some distance over time. Yeah, so question 1, we measured 5,000 kilometers, right? So we're going to have 5,000 kilometers. Then we're going to divide those 5,000 kilometers by the time, whatever time you got in problem 2. For question 4 here, we're looking at converting that distance over time, because here we have it in kilometers per million years. Here we want to convert them to centimeters per year. Now, in geology, when we're looking at tectonic spreading rates or tectonic motions, we do it in centimeters per year. So I'm going to give you kind of the rule of thumb, the easy way to do it. Let's say we had, let's just pick one of these. Let's say we had 83 kilometers per million years, 83 kilometers. So one rule is kilometers per million years is the same thing as saying 83 millimeters per year. Here, I'm going to find that I need to make it 8.3 centimeters per year. So I don't think 83 kilometers per million years is the correct answer because I don't see that option here. I see 5.8. That might be the answer here. So, for example, this would convert to 58 kilometers per million years would convert to 58 millimeters per year, which would be 5.8 centimeters per year, right? So that may be the answer there, but you'd have to check it out based on what you get. So they want us to go to the gallery and make sure the volcanoes are off. So if we go down here to the gallery and we go down, we want to turn the volcanoes on, right? So that's going to show us where the volcanoes occur. So going back to our question, the northwest trending Red Sea is a linear sea that is opening northeast southwest. So the Red Sea is this sea right here. It's opening northwest southeast. That's correct. The east-northeast trending Gulf of Aden is a linear sea that is opening in a north-northwest south-southeast direction. So let's look at that. So here's the Gulf of Aden. So north-northwest south-southeast. So north-northwest south-southeast it is opening in the northwest south, so that's correct as well. So this one's correct, this one's correct. The volcanoes in Africa define a linear rift that is opening in a northwest southeast direction. So let's see, so here's the East African Rift. So northwest south, yes, that's correct as well. So this one, northwest southeast, that's correct as well. The volcanoes in Africa define, oh, that's the false one right there, because a volcanic arc requires a subduction zone, right? And there, if you look here, there's no ocean trench. We're seeing divergent boundaries all the way around here. Subduction ultimately produces a volcanic arc on the overriding plate, right? What is the depth of the majority of earthquakes directly beneath the volcanic arc in the Mariana Trench? So let's go to problem 3B here. So 3B. So the Mariana Trench, well, that's one of the deepest places on Earth, and where the Pacific plate is subducting into this trench right here, right? And so this Pacific plate is subducting under this tectonic plate, and here's a chain of volcanoes. And so these different colors here are focal depths. Remember, the focus of an earthquake is the point deep in Earth where the earthquake initiates, where it begins. And then up here on Earth's surface would be the epicenter. But really the earthquake begins at the focus, which is some depth. And you can see the focal depths. So these are relatively shallow, 0 to 50 kilometers. We get to the orange, this kind of browny orange color, that's 51 to 100 kilometers. And you can see that right under the volcanic arc here, they're primarily red color, which is 101 to 200 kilometers. Then they ask you to measure the arc trench gap. So the arc trench gap is going to be the distance between the trench and the chain of volcanoes. So let's measure that real quick. And so if we use our ruler tool up here, right, well, let's just do a line because it's going to be a straight line. So we got the chain of volcanoes here. Problem 3, so we want to measure between this place mark and this place mark. So we'll put a line there and a line there, and we have about 200 kilometers, right? So let's see what are the options. So about 212. In fact, let's do problem 16 because this talks about fracture zones and active parts of the fracture zones and inactive parts. And so your book does a good job at explaining this, but let me just show you some features. As we go to problems 4, let's go to this problem 4. And for this problem, because we're looking at the mid-oceanic ridge and we want to see these fracture zones, the ages, the map kind of gets in the way. So I'm just going to turn that off. So we'll just turn off the seafloor ages. Now I can clearly see the fracture zones, right? And so this here is the mid-oceanic ridge, and it's offset. There's another mid-oceanic ridge over here. The regions between the mid-oceanic ridge, between here and here, this is the active part of the fracture zone. It's active. There are earthquakes. In fact, there's an earthquake right there. Here's another earthquake there. So earthquakes occur on the active parts of the plate tectonic margins. Another way to think about it, let's say this is plate tectonic A, a tectonic plate A. Here's another tectonic plate over here. We'll call this B. And so plate B and plate A are in contact at the mid-oceanic ridge. Plate A and plate B are in contact at the active part of the fracture zone, and they're also in contact over here. Now this other part over here, you know, for I and for C2, these areas, they're all along the same plate. They're both, the tectonic plate A is here, tectonic plate here, plate A is here as well. So this is the inactive part. There are no earthquakes over here. This is inactive as well. And so that's how we're going to look at these fracture zones. So that'll kind of help you with answering this question here. So in this question 17, in what direction are place marks 4B1 and 4B2 moving respectively? So 4B1 and 4B2. So let's look at those. 4B1 and 4B2 here. So 4B1 is moving toward the east. 4B2 is moving toward the west, right? Because it's on this plate over here. So 4B2 is moving toward the left or the west. 4B1 is moving toward the east. Yeah, so 4B1 is moving toward the east. 4B2 is, so it'd be this one here. And for 4C1 and 4C2, so 4C1 and 4C, well, they're both on the same tectonic plate, so they're both moving west. Because if we kind of take a look at that again, remember, here's a divergent boundary, here's the divergent boundary. This seafloor is moving toward the west, this seafloor is moving to the west, right? And they just happen to be in a fracture zone. This is inactive fracture zone. They're both moving west. So anyhow, I hope this helps a little bit. Some of you asked me to do a little demo on this. And so here are some tricks. So see you next time.